Welcome to episode 2 of the School Science Shed, a series of videos which are aimed to help you revise for your physics GCSE if you are studying in England. Now, if you're not in England, I still hope it's going to be helpful because obviously physics is the same everywhere in the world, but you will need to be careful to make sure that what I'm covering matches your curriculum. And that's true even if you are in England. There are different requirements for different exam boards, so you can't rely on this alone as a revision source, and you must check your syllabus to make sure you've covered everything that you need to. In this episode, we are going to talk about energy stores and energy transfers. One of the most interesting things about energy is that it can occur in different forms. And in some of those forms, it can be stored, and we've got a list on this slide here of the different forms in which energy can be stored. And when we're talking about energy in these forms, we sometimes talk about them rather than being energy forms. Because energy can be stored in those forms, we sometimes call them energy stores. So we might talk about energy being stored as chemical energy, or alternatively, another way of saying the same thing would be to say the energy is in the chemical store. We might say a fuel tank full of petrol has energy in the chemical store. We might say that a hot water bottle has energy in the thermal store, or we might say, and it means exactly the same thing, a hot water bottle is a store of thermal energy. So those 8 forms of energy there are sometimes called energy stores. There are some forms of energy where it's really difficult to store energy in those forms, but those forms of energy do transfer energy, and we sometimes call these energy transfers. So we might talk about energy being transferred from a light bulb into a room as light, or we might talk about energy being transferred electrically if an electrical appliance is working. And while we're talking about transfer, it's also possible to transfer energy mechanically directly by using forces. So if you were to push a table across the floor, you would be transferring energy to that table mechanically because you'd be directly in contact with it. So that's what we mean by a mechanical transfer. So let's take a look at these different forms of energy and talk about them. So first of all, we have here chemical energy, and we've got pictures of 4 things that store energy as chemical energy, or another way of saying that would be to say that they all have energy in the chemical store. So this first picture here, I don't know how well you recognise it, but it's somebody burning some magnesium. So the magnesium and oxygen, before they burn, have energy stored in them. It's in the form of chemical energy, or the energy is in the chemical store. And then when they burn, when the magnesium combines with the oxygen, that energy is transferred into other forms, in this particular case, thermal energy and light. So magnesium and oxygen together is an example of something that has chemical energy or stores energy in the chemical store. And this picture here shows a can of diesel fuel. And if you think carefully about what we've already said about magnesium, it should be clear to you that all fuels are a store of chemical energy. They all have energy in the chemical store, because the idea of fuels is you burn them, you combine them with oxygen, and that's how you get the energy out that you need. That's how you transfer the energy into different forms. So diesel is an example of a fuel, and all fuels contain energy in the chemical store. This delicious looking cake here, well, that's an example of food, because food stores chemical energy. Like combustion, combining with oxygen, is a chemical reaction, so is respiration, which is how energy is transferred in our bodies. And we use things from food for respiration. So food is a store of chemical energy. And then the last picture I've deliberately chosen because it's one that very often catches people out. So it's one you need to be careful about. Those pictures of what for now I'm going to call batteries, but when we come to look at electricity, I'll explain why more properly we ought to call them cells. So in these batteries there are chemicals which react, and when they react they transfer energy electrically. So it's chemicals in there that are storing the energy. So the energy is in the chemical store, or in a battery you've got a store of chemical energy. And here's a definition of chemical energy for you. This talks about a system here. And towards the end of the video, I'm going to explain exactly what a system is. But basically, in those examples, the system are the different chemicals that are reacting together. So let's have a look at thermal energy. So we've got a definition there. Thermal energy is stored in objects because they are hot. And we've got some examples here. This is a wheat bag. You put that in the microwave and you warm it up. And then if you've got muscle pain somewhere, you can put it against the muscle that hurts, and that will make the muscle feel better. Hot cup of tea also has energy in the thermal store. And the blacksmith here has heated up this iron rod in order to make it soft so it can be hammered into shape. And while it's hot, that iron rod has energy in the thermal store. It stores thermal energy. Nuclear energy is energy that is stored in an object because it can be transferred by a nuclear reaction. So in all of these three pictures, we might say that there is energy in the nuclear store. These are pellets of nuclear fuel, uranium fuel, and these could be used in a power station, nuclear power station. This is a container for collecting radioactive waste for careful disposal. The waste in there will store energy as nuclear energy because it's radioactive. And then this thing is something that's very difficult to photograph. It's actually a picture of the sun. And the reason it's been included in this list of things that have got energy in the nuclear store is because the sun transfers energy by a nuclear reaction. So there's a nuclear reaction going on in the sun, which we'll talk more about when we talk about radioactivity. There's a nuclear reaction going on in the sun, which is transferring energy into thermal energy and light, which then reaches us from the sun. So that's nuclear energy. Kinetic energy. Now, I'm afraid that physicists have given this a pretentious name. What they should have called it is movement energy. And if they called it movement energy, you would have no trouble at all in understanding what they were talking about. The Greek letter, ancient Greek letter kinesis, means movement. So they've taken that letter and they've used it to name this particular type of energy. So we've got some examples here of things that are moving. So we've got the sports car, we've got the train, and we've got this nice little gif here of a spinning top as well. All of those have got kinetic energy. They've all got energy in the kinetic store. Now, you might be thinking that you can see that kinetic energy is a form of energy, but you can't really see how energy could be stored as kinetic energy. So have a look at this video of a toy that uses a flywheel. A flywheel is a heavy wheel that spins round to store energy. And what you'll see in the video is that the wheel gets spinning, and then the energy from that wheel is transferred to the car to make it go. So having watched it, you should be really confident that kinetic energy is a store of energy. let's move on and talk about gravitational potential energy. So gravitational potential energy is to do with objects that are high up. They're storing energy because they're high up. And again, we could either say they store energy as gravitational potential energy, or we might say the energy is in the gravitational potential store. And here are some examples of things which have energy in the gravitational potential store. So on this side, on the left hand side of the screen, we've got a roller coaster, and the way most roller coasters work is that there is a motor which lifts the roller coaster to the highest point, and at that point it's got lots of energy because it's high up, and the energy is gravitational potential energy. And then as it goes round the actual track of the roller coaster, that gravitational potential energy is transferred mostly into kinetic energy to make the roller coaster move fast. And this is a hydroelectric power station. So there's a dam to trap some water. Behind the dam there's some water which is higher here than the water here. So this is storing energy as gravitational potential energy, and if we let it flow out, we can use the flowing water to turn a turbine and generate electricity. So those are examples of gravitational potential energy. Elastic potential energy is to do with things that have had their shape changed and they're ready to spring back. So if you stretch something or squash something or bend something or twist something and it's ready to spring back, it's storing elastic potential energy. Or if you want to put it another way, it's got energy in the elastic potential energy store. And here are some examples, couple of examples of things that have got energy in the elastic potential store. So first of all, we've got a catapult, which you obviously, when you stretch to pull it back, you are storing energy in the stretched elastic, and then when you let go, that's transferred to the kinetic energy of the stone that you're firing. And here we've got a very nice looking clockwork toy. They don't really make toys like this anymore, do they? So what we've got here, there's inside the mechanism there is a spiral spring, and when you turn the key you are tightening that spiral spring up, and then when you take the key out and you let it go, the spiral spring loosens up, and because it was twisted before and it sprung back, when it's twisted, it's got energy in the elastic potential energy store. You can also have energy stored in the magnetic, using magnetic or electrostatic fields. So electrostatic are things to do with static electricity, and I'm sure you're familiar with magnets. And the forces within those fields enable you to store energy as well. And we've got a little video here which is showing how you can store energy with magnets. So here we've got two magnets and the poles are the same, so they're attracted to each other. So when they're held apart as they were, you've got energy stored, and then when you let go, they come together. These are really strong magnets, but they're quite brittle. Look, I've actually broken that one by not being careful enough. So let's take that one away and we will have a look at the next one. So now what we're doing is we're putting them so they're repelling, and then they're going to push apart. There we go. Make sure they really are repelling. Make sure they don't pull together. Let's try it again. Here we go. Pushing apart, let go, and they fly apart. So because of those magnetic or electrostatic forces, we've got some energy being stored, and we say they're stored as magnetic or electrostatic potential energy. So that's the energy stores, the way that energy can be in a form where it can be stored. Let's have a look at the energy transfers. So energy can be transferred as either light or sound. And strictly speaking, if we're talking about light, there are other forms of waves which are similar to light called the electromagnetic spectrum, and any part of the electromagnetic spectrum can transfer energy. And when we do the waves topic, we'll talk in a bit more detail about the electromagnetic spectrum. and it can be also energy can be transferred as the vibrations of sound. And we've got a little picture here showing energy being transferred as light. So in the bulb, energy is transferred electrically into light and thermal energy, and then the light waves spread out into the room, transferring energy to all different parts of the room. And when it's transferred, it can also be reflected. You can see it bouncing off the walls there. So light can transfer energy from one place to another. And sound is the same. If you want to think about how you're hearing my voice, somewhere on your phone or your computer or your tablet there is a loudspeaker, and this shows how a loudspeaker works. Loudspeakers have a thin layer called a diaphragm that vibrates backwards and forwards. It's normally made out of card. It vibrates backwards and forwards, and as it vibrates backwards and forwards it squashes and stretches the air, and then these squashes and stretches move through the air, and when they reach your eardrum they make your eardrum move. They're transferring energy from the diaphragm to your ear. More properly, these squashes and stretches are called compressions and rarefactions. And again, when we study waves, I'll explain to you a little bit more about how sound waves are produced and how they move. But the key idea for now is that the sound is transferring energy from the diaphragm into the air. And energy can also be transferred electrically as well. So if we've got this is the same circuit, it's just on this side it's switched off and on this side it's switched on. So what have we got? We've got some cells there. We've got 12 volts, and in each of those cells we've got a store of chemical energy. And then when the circuit is switched on, that chemical energy is transferred electrically to the bulb, and it's transferred in the bulb to thermal energy and light. So that's an example of energy being transferred electrically. Now there's a really important fact about energy and these forms that we've been talking about, and that is that energy cannot be created or destroyed. The only thing you can do with energy is transfer it from one form or one place to another. And what that means is that the total energy at the beginning of your process is going to be the same as the total energy at the end. And a precise physics way of saying that is the total energy in a closed system is constant. And this idea is known as the principle of conservation of energy. You can't create energy, you can't destroy it, you can only transfer it from one form or one place to another. And that means the total energy in a closed system is constant. And right at the start of this video, I promised that I would tell you what a system was. So here we go. A system is a group of objects interacting with each other. And if energy can't be transferred in or out of the system, then we call it a closed system. And because energy can't be created or destroyed, if you can't transfer energy in or out of a system, then the total amount of energy in that system is going to stay the same. Let's have a look at some examples of systems so we're just really clear about what we mean. So this system here is the archer and her bow and her arrow. Those are three objects, they're all interacting. That is a system. We've got a much bigger system in the middle, that's a galaxy. So all of the stars and the black hole in the centre of the galaxy and the clouds of dust and gas and any planets and moons that there might be, they're all interacting with each other, mostly through the force of gravity. That is a system. And on the right, we've got a very tiny system, which is an atom, which is made of protons and electrons and neutrons, and again they're all interacting with each other, so all three of those things are systems. So that takes us to the end of this video, and where we've covered what we mean by energy stores and energy transfers. I hope it was useful for you in your revision, and if it was, why don't you give it a thumbs up? If you've got any questions about anything that's been covered, put those in the comments and I'll do my best to answer them, either by typing an answer or I might later on do a video where I answer some of the most important questions. I've really enjoyed explaining this section of physics to you, and I'm very much looking forward to the next one, episode 3. But until then, good luck with your revision, and I will speak to you soon.